At the start of the fall 2020 semester, our group of 4 mechanical engineering students was tasked with developing a device or process to prepare tensile test specimens out of plastic and composite sheets. Tensile tests are a widely used method of evaluating the mechanical properties of a material. To help ensure that testing procedures of similar materials are consistent, the American Society for Testing and Materials produces a variety of manuals for a multitude of different materials. These standardized tests ensure that test results are consistent and repeatable regardless of who performs the test or where it's done. There are many different means of producing the specimens for these tests. For example, many plastic specimens can be injection molded. However, this isn't suitable for all materials. Certain orientations of fiber reinforced composites can't be injection molded, and some materials are already formed into sheets before testing. In this case, the specimen must be cut from raw or pre-processed material. Before we started the design process, we broke down the project into a series of constraints that our design would need to satisfy. After we had laid out the constraints, we decided to break down what the device would need to be able to do from a design perspective even further. In response to these constraints, 5 different concepts were generated: a hole punch, a water jet cutter, a CNC router, a CNC scroll saw, and a key duplicator-like mechanism were proposed. After the design was finalized, it was evaluated using ANSYS static structural to determine how much deformation the mechanism would experience under the loads associated with cutting. It was ultimately determined that the design was suitable, so the design group moved on to fabrication. A collection of flat aluminum parts were outsourced to a local metal fabrication company for laser cutting and bending to help facilitate the build process. This significantly jump-started our early progress. From there, the T-slot aluminum extrusion was used for the base frame because of its ease of use and adjustability. After the base frame was completed, the arms that attach the upper assembly to the lower assembly were connected to a set of linear rails that roll on small ball bearings, and the cutting base was prepared to be attached. The cutting base consists of a 5/8 inch thick plywood base with threaded inserts attached. These inserts provide a point to clamp the material down to the cutting base. Once the upper assembly was attached, a handheld router was mounted using custom clamps made at NDSU with the wire EDM cutter. With the router attached, all that remained was integrating the control system. A Raspberry Pi sends machine instructions to an Arduino Uno, which interprets and redirects those instructions to the motor controllers, which then provide power to the stepper motors. With the device complete and electronics on board, it's now time for testing, just not as much time as we would like. Significant delays were experienced in the fabrication of custom parts at NDSU, as well as converting the CAD models into machine instructions. This left very little time at the end of the semester for extensive testing of the specimen cutter. While it can cut materials, it cannot be verified that it cuts accurately or precisely enough to be considered a success. Further work is required to verify that the device cuts within the ASTM specified tolerances. Thorough testing is required on the optimal cutting speed and feed rate for different types of materials, as well as the optimal cutting tools. We would like to thank Dr. Ali Amiri, Dr. Long Jiang, and Damian Mohawk for their guidance throughout this project. We would also like to thank Dr. Alan Kallmeyer and the North Dakota State University Mechanical Engineering Department for their contribution to this project, as well as to our education over the past 4 years. It's been an honor to learn here and test the knowledge that we've obtained on this project.